metaphysics is looking at. Okay, so he said, science frame eminently empirical. There is a sharp distinction between science and metaphysics. Science is empirical and subjected to experiment. Metaphysics is not. You won't find a lot, the word laboratory of metaphysics, except in cartoons. Make fun. So science and metaphysics are to be kept, and that's a big, actually, change if you think about, what we talked about, like we talked about Newton and Leibniz, we talked about Descartes, Hume, all share the view that metaphysics is part of. That metaphysical discussion is important to science and to understand science. What is the nature of science according to the view? It's pre-eminently rational. It's actually superior to other, so that's why people tell you be scientific. About things that are read or something. Be quantitative, like numbers speak volumes. To come up with numbers, they're more convincing, they're more rational. We do a lot of statistics. This is economics. And I was going to study economics. I thought it would be like political economy, but then more statistics. Science explores the nature of reality, is objectivist in the view. So science can find out about the world, it's not just our invention or imposition on the world. Scientific progress brings us closer to the truth about the world. So our new theories are more accurate, more informative, more true, more approximately true than the previous ones. Good scientific theories describe approximately the way the world is. So Newton described approximately general relativity, Newton's theory of gravitation, general theory of relativity described even better, considered one of the most precise theories in the history of science. You get like 12, 14 digits after the point. That's not good. Good scientific theory do not only describe the world, they explain it. The explanation of such theories give the such theory give our objective, it's not just our invention. And the idea that there is a scientific method that is correct for all sciences for all times. And actually, the idea of this scientific method, as Ayer emphasized, was influenced by the conception of natural sciences and mainly physics. Physics is considered as the queen of sciences, and learning from physics and thinking about physics is kind of a paradigm of how science should be done. It's the way they guided, the logical positivism. And if you think about it, the social sciences became empty of the. So economics is done very much nowadays like physics. They use the mathematics, their models. Even when some argue that these models seem to be totally baloney, that they are kind of too idealized, too abstract to tell us something. The assumption, seems to be totally implausible. Just for mathematical reasons. Some criticize, economics, that's what we do. And in political economy, the way of thinking about economics is a more broad way, and connecting it to politics and political philosophy is something that is dying in economics. Very few. Usually people who are before retirement or after retirement. Scientific method and scientific knowledge. So let's take out. There's a book that in the scientific method that we didn't agree discuss on the method. The scientific method, which is supposed to be similar in all branches of science, is what makes science successful. So the argument is that modern science is better than previous science because modern science has a better methodology. It has a better experimental method. Checking things. Not just checking with statistical hypotheses. Whether you do like social or natural sciences, when you start to do experimental science, you use a lot of statistics. Many times the computer does it for you. So you may not know what the computer does, but it has some problem. Hopefully they do it well. The scientific method is what makes scientific knowledge superior. It's because it's much more methodological and kind of intuitive and everyday thinking. It's based on logic, based on rigorous mathematical framework, and it's critical. The fact that it's empirical is not like the Middle Ages scholastic philosophy in which you read, Aristotle and believe, or you read some ancient texts about medicine, and you draw the body according to the text. You go and do the experiments. You do cross experiments. You publish it publicly, and other people do the same experiments and so on. In order to publish, you have to have referees to journal, and it's blind referees, sometimes double blind. What the referees and the authors don't know about each other. The identity of each other. What is the scientific method? It's kind of complicated. If you take more advanced courses, you can talk about it, but part of it is confirmation, for instance, cooperation. These things are well discussed in the context of the scientific method. People talked about what is the concept of confirmation, how to do well experiments, which theory to choose, for instance, sequence theory, theories that are more informative, theories that integrate well with other theories, and so on. And the scientific method is based on our best inductive reasoning. So the idea is that in science, induction is more rigorous and better. And that's the reason why science is considered as superior. If I go and tell a prime minister what I think about economics, they wouldn't listen to me, they would listen to a professor from the University of Rome. Because they use, the science. I use like more language. And the evolution of science. According to the received view, the evolution of science is linear. It accumulates, become more and more, better and better. It's not that suddenly, we go from good science to no science whatsoever, and then something else. It accumulates over time. We just know more. We have Newton's theory, but now we have general relativity, so we know better. We have classical physics, but now we have quantum mechanics, so we know better. The classical and quantum. We learn some very curious things about nature. We learn, for instance, that maybe nature is not continuous. That energy varies by quantums, and so on. We learn about the structure of the atoms. So we have a table now that tells us that we can think about all kinds of atoms that exist and the properties and so on. So new theories supersede the old ones. They describe broader range of phenomena, better accuracy. They are more approximately true about the world. An example, as we said, general relativity replaced Newtonian mechanics. So we can use Newtonian because it's simple, relatively simple, but we don't think that it's true anymore. So that's the view. The view is that science, it's reassuring because science, I mean, is getting closer and closer to the truth. That's the view. You ask scientists, they will definitely tell you that. I mean, there is a progress, and there's the reason many times why people look down at previous times. It was fine. It was very intelligent. It was a different time. Now we know much better. We have a better method. We make more experiments. We accumulate more. So. And the received view think that they have a lot of support in historical data in the history of science. So, for instance, we can see general relativity accounts. We said better than Newton theory, and quantum mechanics is much better than classical physics in that sense, and there are many others. So far, it's rational, it's empirical, against metaphysics, broadly speaking, or at least metaphysics is less important. It is progressive, it's getting us closer to the truth. It takes a long time, we may never get, to the truth, but we take closer and closer. Another element, it has the best method. Might improve it, but it's getting better and better. Another aspect of the received view is the distinction between the context of discovery and the context of evaluation or context of justification. We already talked about it in Popper's philosophy, that we said that what is important or what is the emphasis of science according to Popper is the evaluation of theory, justification of theory, and the discovery is a matter of psychology. So the idea is that not everything in science is rational, scientific invention and construction, more generally everything that is related to the so-called context of discovery of scientific theories and hypotheses are not generally rational. Or they need not be irrational, but they are not rational in the sense that they are not based. There is no methodology or school of teaching how to be Einstein. If there was, there would be a long queue there. There is nobody believe that. It's not a chance, It's like maybe education could help, but someone is kind of born genius, and people talk about genius. But you cannot teach. You can teach the physics, and you can hope that people will do well later on, or you can teach the economics and hope. But this is something that is not part of the rational part of science, and you cannot teach it. What you can do is teach scientists how to be methodological in the experiments and evaluation. So confirmation of theories and selection of theories out of number of theories is a rational thing, and therefore the logical positivists actually spend a lot of time on theory of confirmation and explanation. Better theories better explained, they are more confirmed, they are more simple, for instance, and so on. So the logical positivism and the philosophy of science following it, has spent a lot of energies in thinking about that, but until recently, very little in thinking about how discoveries are made. And studying it, this is kind of psychology, it's not philosophy. You can have the experiment, or you can have a study of the difference between Einstein and normal person. You can even have his brain, like in the laboratory, research, and study what's the difference in his brain, between his brain and others. But not philosophical. Nobody does like philosophy of why Einstein, or at least really listen to nobody. So we said that Popper's philosophy of there are some non-ideal aspects of science. Scientists have ego, like everybody else. If they get famous for something, they don't like the idea of falsifying. So some of them may not think about it, or not try really like Popper said, to falsify it. Others may go even farther and not publish in certain experiments or results that they might practically do. Scientists sometimes plagiarize. Like you, I had the neighbor, the daughter of a professor in my neighbor, and it's actually a famous professor of economics, but he died on the thing. Still at the university. Amazing. And he's famous. It's not that he's not famous. And he was already famous. So it happens. We say that the science is critical. For instance, referees of journals, they're supposed to be critical, fair-minded, blah, blah, blah. But many times when you get referee reports, you see that it's not exactly. You see that they are like political parties, people who believe in a certain theory, who send them in like a paper or philosophy paper that has a different view. They might just reject it, not because it's not good in itself, but because it doesn't seem really good. Some people think that it's not only, sometimes it's kind of systematic, that the referee process is kind of like a lottery. There was an experiment in psychology, and that people, that the experimenter took 20 papers that were published in reputable journals by reputable professors and changed the name from reputable institution, changed the name of the authors and the institutional affiliation and send them back to refugees. What were the results? Yeah, if I remember, well, 16 of them were flatly rejected and 4 were found plagiarized. So the referees knew that someone else owned the same paper as the second. So, one cannot deny that there are these, that they are kind of, that scientists could be cheap, could be dogmatic. They don't want to know about other things. And they're educated sometimes like that. So there are different things that seem to be non-ideal. It's not the romantic view of a scientist that just stay outside, look at the sky and just open-minded and willing to change the mind every day. But that's not the view. But according to the received view, this is the exception. The overall, although science might not be without all these non-ideal characteristics, overall, it's the more rational endeavor, and in the long run, all these non-ideal character does not really change the evolution. It's like noise. Whenever you receive in your TV or radio, you receive the main, the main information or the main, and then there is a noise on them. So a good TV or good radio will kind of filter out the noise. But there is always noise. So the idea is that this is a kind of noise that in the long run, if you wait long enough, and you check by, so if someone cheat, for instance, then someone else in another laboratory would do the same test, and some other person would look at the paper, and at some point they will find, that it was a cheat, or it was wrong, or something like that, and bring them back to the truth, approximately. So if you think it's something like that, there is the main signal, and the main signal going up to the truth. This is the truth, and this is time, but it's not an easy, not a kind of smooth going up. There might be all these things that are influenced by social factors. So what we have, is like in the long run, there is, so you can never know, what will happen in the short run. There might be social influence. There could be things that will influence the development. But at some point, the truth and the way the world is and the scientific method will win against this. Social influence is a kind of like noise. Cultural biases, social biases, racial biases, whatever. These things are, again, other courses like HPS100H1, for instance, one of the papers is about bias in the biological, gender bias in the biological science. So for instance, the sperm is supposed to be like the active and the egg is the passive. Which was influenced by cultural views and was very much and seriously held until the end of the 19th century. And different experiments that show, for instance, that this view is impossible, then people change it to another bias. Or people to another bias. So biases are not easy to approve, but the idea is that in the long run now, people don't believe in this bias. They have the view that the egg is also maybe active and the sperm is more complicated to store and so on. So you have to wait 50 years or more, half a century, but at some point, we get to the truth approximately. So this is the view. Do you recognize this view of science? No? You don't recognize this view of science? Don't think about that philosophers. How many recognize this view as kind of broadly describing? How many think that this is not the view of study science? Okay, anyway. This is believed by many to be the received view or element of the received view. It was, as I said, very much influenced by logical positivism. Logical positivism, by the way, has been heavily criticized in philosophy, but is still very much ruling philosophy or influential philosophy in the sciences. And although they don't really say what we say, they did influence and shape a lot of these aspects of these views to different levels and degrees. So what we are going to do next time, we will talk about harpoon philosophy and book. Actually revolutionized. And this view is extremely different.
What is the exam?
The exam?
And you argue that by looking at the history of science, you get a very, very different picture of what science is.
Oh, no. I know it's late, bro.
And this view has been very important in the last 50 years. Another thing, just in closing, that I mentioned, that I posted the review questions for the final exam. So please look at it during the questions about them. We will have reviews after the exam.